All right, guys, here's the video for the probability. So for number 91, sorry, a store has 15 sofas, 12 lamps, 10 tables. So let's kind of underline that so we see what we're looking at here. At half price, how many different combinations of a sofa, a lamp, and a table can be bought at the sale? So you guys look, you have 15 sofas. It's just like how many different ways can you put these together? And then there's 12, and then there's 10. So it's just 15 times 12 times 10, which if you plug that into your calculator or my phone, 15 times 12 times 10, that should be 1,800. So easy little problem, right? Okay, 92, a car dealer offers a choice of 6 vinyl top colors, 18 body colors, and 7 upholstery colors. How many different color combinations are there? So again, you have 6 times 18 times 7. 6 times 18 times 7, that's going to be 756. Okay, so easy little problem, don't miss it. Okay, what is the value of this, you guys, was just another notation. It's just 8, choose 3. I think that's how we saw it, right? Okay, so on this one, we are giving you this formula, so you don't have to memorize it. Okay, it is on your cheat sheet that I gave you on Friday. So this is your N, this is your R. So if you plug that in, you're going to get 8 factorial over 8 minus 3 factorial times 3 factorial, which is going to be 8 factorial over 5 factorial, 3 factorial. And remember, we're always going to break down the biggest factorial that we see until we hit the next biggest one, okay? So this is going to be 8 times 7 times 6 times, oh, I hit the 5, stop there, all over 5 factorial, 3 factorial. So these guys cancel out. You guys, 3 factorial is 3 times 2, which is 6. So these guys cancel out. And we're just left with 8 times 7, which is 56. Okay? Same thing for number 94. This is your N, this is your R. So it's going to be 25 factorial over 25 minus 5 factorial. Yikes, times 5 factorial. So again, we're always going to start with the highest factorial that we see. So it's going to be, actually, let me rewrite this one more time. This is 25 factorial over 25 minus 5 is 20 factorial times 5 factorial. So this is going to be 25 times 24 times 23 times 22 times 21 times 20 factorial. I'm stopping at this one. And then it's all over 20 factorial times 5 factorial. Kind of a big one. If this was on the note calculator section, it would definitely be smaller. So you guys, multiplying the top part out, actually, I'm going to try to do it without a calculator because I'm cool. 25 times 24 times 23 times 22 times 21, all over 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, so let's cross some of these guys out. 5 goes into 25 5 times. 4 goes into 24 6 times. 3 goes into 21 7 times. And 2 goes into 22 11 times. So I'm really just left with 5 times 6 times 23 times 11 times 7. And I'm going to use my calculator for that. Okay, so I have 5 times 6 times 11 times 23 times 7. And I got kind of a big number here, 53,130. Give me 1 second. I need to check on my dog to see if he ran away. Hang on 1 second. I don't want to stop the video because then I don't know how to like paste it together. Max, come here. Max, come. Max, come here. Oh, you're such a bad dog. Come on, buddy. Max, come. Max, do you want a cookie? Come on. Good boy. I just lied to my dog that I'm going to give him a cookie. It's not very nice of me. Okay, go inside. Give him a cookie. This is all on the video, by the way. Okay. Back to probability. Okay, what is the value of, and remember the way we wrote this was NPR, a permutation. And remember the formula for this one is N factorial over N minus R factorial. And again, that will be given to you. So this is your N, this is your R. So this is 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial. Again, breaking it down, 6 times 5 times 4 times 3 factorial over 3 factorial, and that's 30 times 4, which is 120. So something like that you should expect to see and be able to do without a calculator. Okay, same thing with this one. Here's your n, here's your r. So this is 15 factorial over 15 minus 7 factorial. So that's 15 factorial over 8 factorial. Breaking that down, I have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial, all over 8 factorial. And this is one heck of a ridiculous problem. I would never do something like this to you on the test, but let's plug that into a calculator. So I have 15 times 14 times 13 times 12 times 11 times 10 times 9. Well, that's a nice number. This is 32,432,400. Oh my gosh, there's a bug out here, sorry. Okay, again, you guys, more like number 95. 96 was dumb. Okay, an urn has 12 black and 8 green marbles. How many ways can 3 black and 2 green marbles be chosen? Okay, so you guys, order does not matter, right? Because it's just colors. So what I'm going to be looking at, I have 12 black marbles and I want to choose 3. So that's going to be 12, choose 3, times, remember we have and means times, right? And then what else do we have here? We have 8 green marbles and we just want to choose 2 of them. So it's going to be times 8, choose 2. Okay, and then you guys, plugging that in, so these are combinations. Let's see if we can figure this out. So for the first one, it's going to be 12 factorial all over 12 minus 3 factorial times 3 factorial, and then times 8 factorial, that's just using the formula from above, over 8 minus 2 factorial times 2 factorial. So on the first one, we're going to have 12 factorial over 12 minus 3 is 9 factorial, 3 factorial, times, and then we have 8 factorial over 8 minus 2 is 6 factorial, 2 factorial. Now, breaking this down, let me do it in a different color, maybe onto the side here. So this guy right here, okay, I'm going to start with the 12, so I have 12 times 11 times 10 times 9 factorial. I'm stopping there because of this 9, and then I have 9 factorial, and you guys, again, 3 factorial is just 6. So these guys cancel out. 6 goes into 12 2 times. That's 22 times 10, which is 220. So that's that green one. And let's do this one in blue. So this guy right here, 8 factorial is 8 times 7 times 6. I'm going to stop there because I've got the 6 factorial that's going to cancel it out. And then 2 factorial is just 2 times 1, which is 2. And then 8 divided by 2, that's just 4. 4 times 7, that's 28. So it's 220 times 28. Oh, let's try that again. 220 times 28, which is 6,160. Okay, same question for number 98. You have 6 men, and you want to have a committee of 2. So that's going to be 6 choose 2. And that means times. You have 4 women, and you want to choose 3. So it's going to be 4 choose 3. Okay, so again, the 6 choose 2. It's going to be 6 factorial over 6 minus 2, which is 4 factorial times 2 factorial, times, and this is going to be 4 factorial over 4 minus 3, which is 1 factorial times 3 factorial. So doing this guy first here, okay, here I'm going to I'll do it in a different color. Here, I'll do it in this like pink color. So 6 factorial is 6 times 5 times 4 factorial times 4 factorial, and 2 factorial is just 2. These cancel. 6 divided by 2 is 3. 3 times 5 is 15. So that's that one. And then maybe do this one in a blue. So this is going to be 4 factorial, 4 times 3 factorial over 1 factorial, which is just 1, and then 3 factorial. These cancel. 4 divided by 1 is 4. 15 times 4 is 60. That wasn't too bad. All right. In her pocket, Linda has 5 nickels, 3 dimes, and 7 pennies. She selects 3 coins. What is the probability that she has selected 3 nickels or 3 pennies? Okay, so you guys, in probability, or means plus, right? So what's the probability that she selected 3 nickels, okay? Well, how many nickels are there? You're going to get a success if you select 3 nickels, right? So I want to have, there's not enough room to do this problem. Okay, so I want to have a nickel, and a nickel, right? Okay, so the first time she selects that nickel, the probability of getting a nickel is going to be 5 out of the total number of coins that you have. So the total is 5 plus 3 plus 7, which is 15. Okay, now you guys, this does not say like without replacement. I think she just reaches in, so like, you know, you shouldn't put the penny back or the nickel back, okay? And then times, okay, the next time she goes into her pocket, one of the nickels is going to be gone, so the probability is going to be 4 out of 14, and the last one's going to be 3 out of 13, okay? Now remember, or means plus. Now I want to select 3 pennies, so I want a penny, penny, penny. Okay, now let's look at the pennies. I have 7 pennies. So the first time she goes in there to select a penny is going to be 7 out of 15. The next time she reaches in, it's going to be 6 out of 14. And the last time it's going to be 5 out of 13. Okay, so you guys, let's calculate what 15 times 14 times 13 is. Okay, so the denominators here are going to be 2,730. Again, I'm using my calculator. And then here, 5 times 4 is 20. 20 times 3 is 60. Plus here, you're going to have, let's see, that's 30 times 7. That's 210. So this is 270 out of 2,730. Okay, and you guys, that looks like it actually reduces. Let me actually plug that in. 270 divided by 2,730. Oh my gosh, I just did that wrong. 270 divided by 2,730. Okay, not very nice. I would just say if you divide by 10, maybe you could do 27 over 273. I think 3 goes into both of those. 3 goes into 27 9 times. 3 goes into 273 91 times. So like 9 over 91. Okay? All right, you guys, I think you're pretty good about number 100 and 101 by now, but let's do it. Okay, 11 factorial. That's 11 times 10 times 9 times 8 times 7 factorial. I'm stopping there because this is the next biggest one. And then 7 factorial, and then 4 factorial is 4 times 3 times 2 times 1. Okay, so let's cancel stuff. So I've got the 7 factorials are gone. You guys, I know 4 times 2 is 8, so it's going to cancel with that one. And then I know that 3 goes into 9 3 times. So this is 30 times 11, which is 330. All right, number 101. Okay, start at 10, so I have 10 times 9 times 8 times 7. Again, I'm stopping at the 7 because of that little dude. And then I have 7 factorial, and 3 factorial is 3 times 2 times 1. Let's cancel some stuff. No, it doesn't work out very well, does it? But it's okay. 3 goes into 9 3 times. 2 goes into 8 4 times. So I'm left with, let's see, that's 12 times 10, which is 120. Okay? All right, almost done with this, actually. Okay, number 102. Find the ax to the 4th y squared term of the binomial expansion of 3x minus 2y to the 6th power. All right, so you guys, I am going to use the binomial theorem, and I'm literally going to go straight to the term that I'm looking for. Remember doing this? Okay, so first things first, I need to figure out what the heck is going to go in here. Okay, that's the easy part. That's going to be this 3x and this negative 2y. Take the sign with it, right? So I'm going to have a 3x and a negative 2y. Okay, now another thing that I see is I actually know the exponents of the x's and y's. The exponent of the x is a 4, and the exponent of the y is a 2. And you guys remember, these two guys add up to make this number on the top. and then whatever this number is this number on the bottom. Okay, so I need to find the actual term here, so let's figure this out. So I have 6 choose 2. That's what this means. Let's figure out what that is. So it's 6 factorial over 6 minus 2, which is 4 factorial times 2 factorial, which is 6 times 5 times 4 factorial over 4 factorial times 2 factorial is just 2 times 1, which is 2. Okay, that goes away. 6 divided by 2 is 3. 3 times 5 is 15. So this guy here is 15. Then I know that 3 to the 4th power is 81. And then x to the 4th power is x to the 4th. I know that negative 2 squared is 4. And then I have that y squared, which is y squared. Okay, so now all I really have to do is multiply these guys together. I'm going to go ahead and use my calculator for that. 15 times 81 times 4. Okay, I keep messing this up. Jeez Louise, let's try that again. 15 times 81 times 4. Okay, so I got 4,860 x to the 4th y squared. And you guys, this is literally one of those problems you cannot just guess on. So you're going to have to do it. You're going to have to work it out. Okay. All right. Let's look at the next one. You toss an unfair coin 5 times. Okay, so you guys, this is like those repeating probabilities, right? Where you do something multiple times and you only have 2 options. You only have heads or tails. Okay, so look, the probability of getting heads, let's write this out. The probability of getting heads is 2 out of 3, which means that the probability of getting tails is 1 out of 3. It's an unfair coin. What is the probability of getting 3 heads and 2 tails? So look, I want to get 3 heads and I want to get 2 tails. Okay, so what am I going to get here? Look, I tossed the coin 5 times. 2 plus 3 is 5, and then this number matches this. Okay, so first I have to find out what this is, which is just 5 choose 2. And that's going to be 5 factorial over 5 minus 2, which is 3 factorial, 2 factorial. So breaking that down, that's 5 times 4 times 3 factorial over 3 factorial times 2 factorial is 2. These cancel. 2 goes into 4 twice. 5 times 2 is 10. So this guy's 10. And now just fill in your probabilities. The probability of getting heads is 2 out of 3. We knew that from here. And to the 3rd power, and the probability of getting tails is 1 out of 3. Now you guys, on this, we are going to let you use your calculator, so you're going to have to figure out what it is. So this is 10 times, okay, 2 to the 3rd is 8, 3 to the 3rd is 27, and then 1 squared is 1, 3 squared is 9. And multiplying the tops there, you're going to get 80 over, let's see, 27 times 9, that's 63, 6, 18, 24 over 243. And you guys, if the answer is given as a decimal, just divide it out. Go 80 divided by 243 on your calculator, and that's what it'll be. Okay, so that there is the probability section. And you guys, I did this video for you guys at a soccer game. So I hope that you can understand that one because it was very loud. All right, I'll see you guys tomorrow. Bye.